All right, my people, this is Kim 112. I want to look at the man they call complex reaction. Let's do this together. What does it mean for a reaction to be complex? In this course, if they ask you whom a complex reaction is, you know what you tell them? Tell them that it's a chemical reaction that takes place in different steps. It's a chemical reaction that has what we call many elementary steps. A chemical reaction that can be formed by the addition of elementary steps. A chemical reaction that has what we call more than one transition stage. A chemical reaction that has more than one propagation stage. A chemical reaction that has one activated complex. We're going to explain all these terminologies. You know, guess what we call reaction mechanism in this course? If you tell somebody that hydrogen and oxygen can come together to form water, yes, we know that atoms of oxygen, they have to react with atoms of hydrogen in order to form water. But there's what we call the step-by-step sequence of events that converts the reactants to product. That's what we call the mechanism of the reaction. If you just don't want to end at oxygen will react with hydrogen to form water, and you want to show the various steps, the sequence of events that actually converts the reactants to product. When you do that, you're describing the mechanism of the reaction. Now, reaction mechanism is divided into three stages. We have what we call initiation stage. I'm talking about reaction mechanism stages. Initiation stage. We have what we call propagation stage. Propagation. And then we have what we call termination stage. Termination. So every chemical reaction in terms of mechanism is divided into three stages: initiation, propagation, and termination. What is happening at the initiation stage? That's where the reacting molecules are colliding. The reacting molecules must collide. And there are many reasons why that should happen. Old bonds have to be broken, new bonds will be formed. It's when you break old bonds and form new bonds and you say you have formed a product. So every chemical reaction involves bond breaking and bond formation. So at the initiation stage of the reaction, the bonds will begin to break. That initiation stage is where the reacting molecules are colliding. Why are they colliding? To produce energy. There's a minimum amount of energy reacting molecules must possess before they can form product. You call that activation energy. That is the minimum amount of energy reacting molecules must possess before product can be formed. That energy is produced at the initiation stage of the reaction. That's one of the reasons reacting molecules are colliding, to produce energy. That energy should cause bond breaking so that new bonds can be formed in what we call product. There's also a minimum amount of energy reacting molecules must possess before they can form product. That energy is produced through effective collision. If the collision taking place at the initiation stage can't produce that energy, the minimum required for the reacting molecules to actually form product, then the reaction will not be spontaneous. Now, by the time we go deeper in this course, you also see that for reaction to be spontaneous, we need energy, a certain amount of energy that can cause unpairing of electrons so that the atoms can exhibit their commonly encountered valency. You remember we discussed hybridization in first semester, okay? So at the initiation stage of the reaction, reacting molecules collide. One of the reasons they collide is to produce energy, and that energy should be enough to cause unpairing of electrons. You remember what we said in the case of carbon? Carbon has configuration of 1s2, 2s2, and 2p2. So if you look at that last p orbital there, it means we have something like this. 1, 2, 3, and then 4. Okay, sorry. We have only 2 electrons there. So it's just 1 and 2. So you see that carbon has 2 unpaired electrons. So it means that carbon should be exhibiting divalency, valency of 2. But that doesn't happen because carbon does not use valency of 2 to form a stable compound. To form a stable compound, carbon needs valency of 4. So what happens? The 2 electrons you have in this s orbital, the 2 electrons you have here must be split into 2, and 1 will now be promoted to the next orbital that is empty. I don't know whether you follow me. Excuse me. So this unpairing of electron requires energy, and that energy is produced at the initiation stage of the reaction through effective collision. So what is the news? At the initiation stage of the chemical reaction, the first stage in reaction mechanism, reacting molecules collide to produce energy. The energy should cause bond breaking. The energy should be able to exceed the minimum required before the chemical reaction can actually occur, which is the activation energy. Some people call it energy barrier. And that energy should be enough to cause unpairing of electrons so that the atoms can exhibit their commonly encountered valency. Carbon is tetravalent. So you should be able to present 4 valent electrons for covalent bonding. But in ground state, carbon has only 2 unpaired electrons. It is when carbon gets excited, which means acquires energy, that it will split the 2 electrons you have here. 1 becomes promoted. Once that happens, carbon will now have 4 valent electrons and can now exhibit the normal tetravalency to form a stable compound. Follow me. At the propagation stage, that is an intermediate stage, a stage where the old bonds are not completely broken and new bonds are not completely formed. That is what we call transition stage. Okay? Now, you see that there are some chemical reactions that have only one transition stage. One transition stage. Remember, when you talk about transition stage, if I have something like this is energy coordinate, and this is reaction pathway, reaction path. If a chemical reaction starts here, the reactants, they will have to climb a certain amount of energy, get to the maximum, and then product will begin to form. If I form the product somewhere here above the reactant, that means that the reaction is endothermic. In endothermic reaction, product is formed above the reactant. Are you with me? Now, starting from where the reaction started to this turning point, that's what we call activation energy. Activation energy. This turning point here, this place is the point of maximum energy. That is what you call activated complex. Activated complex. That is what you call propagation stage. That is what you call transition stage. That is the intermediate point, the maximum point. Are you with me? The transition stage, where the old bonds are not completely broken and new bonds are not completely formed. So some chemical reactions have only one transition state, only one propagation state, only one activated complex. Such a reaction that has only one propagation stage is called elementary reaction. But a complex reaction has more than one transition state. I don't know whether you follow me. So if they ask you what is a complex reaction, you can simply tell them there is a chemical reaction that has more than one transition state. Now let's make it clearer. If I represent somebody like this, let me show you something. Let's say we have CO, carbon 2 oxide, can react with oxygen, half molecules of that, to form CO2. Take a look at this. CO plus half O2 can give you CO2. Now, follow me. Again, carbon plus half oxygen can give you CO. Let me call this equation 1, call this equation 2. Now, notice something. If I add the two equations together, equation 1 plus equation 2, let's see what it gives us.